Good morning! So this problem says points Y and Z represent two different locations of items on a scavenger hunt map. If the scale of the map is 1 unit equals 50 meters, so that's the distance between two dots, that's 50 meters, what is the shortest distance between point Y and point Z? There are two different ways to solve this problem. They're related to each other. I'm going to show you first using the Pythagorean theorem. So we know that the shortest distance between 2 points, well, we know that we can draw a right triangle here. Okay, we go 4 units to the right, 3 units up. Wait, we're missing some dots here. 1, 2, 3 units compose this leg. 1, 2, 3 units compose this leg. Is it shortest to get to Z from Y by going 3 units to the right and then 3 units up? Probably not. We know that the shortest distance is the hypotenuse of the triangle. Pythagorean theorem is a squared plus b squared equals c squared. We call your legs A and B, and we call the hypotenuse C. And we don't know what this distance is. That's what we're trying to find. But we do know the distance A and the distance B. We know that the distance A, this leg of this right triangle, is 3 units. But up here we were told that 1 unit equals 50 meters. This is a real-world problem, so we need to think, if this were like a city or a map of a city or a neighborhood, what does this distance represent? Well, if 1 unit is 50 meters and we have 3 units, we have 150 meters. Actually, I'm going to write that in red. So we're going to color code this here. So leg A is 150 meters. Leg B is the same distance. So it doesn't matter which leg I call A, which leg I call B, but I'm going to substitute those values into my Pythagorean theorem equation. So I have 150 meters squared plus my B value, my other leg, is also 150 meters squared. And that is going to equal my C value, my hypotenuse, the shortest distance, what I'm trying to solve, between points Y and Z squared. So now I'm going to do some calculations. 150 meters squared equals 22,500 meters. So that means my leg B is also going to be that, because they're the same distance. And that is still going to be equaling my hypotenuse squared. Okay? I'm going to add these two figures. So 22,500 plus 22,500 equals, ooh, big number, 45, I don't know where that accent came from, 45,000 meters. Ooh, this is meters squared since I squared my units there also. 45,000 meters squared equals c squared. Now, I want to find c. I don't want to know what c squared is. I also know that a distance is going to be in meters, not in meters squared. Meters squared is going to give us an area measurement. So I need to isolate c. C is being squared. The inverse of squaring something, or the opposite, is to take the square root. Now, if I take the square root of one side of my equation, I'm going to unbalance my equation. So I need to do the same thing to both sides. If I have an equation and I add a popsicle stick to one side, it sinks. I need to rebalance this equation, so I have to add a popsicle stick to the other side. Same with square rooting. I'm square rooting, so I need to square root the other side. Cool. So the square root of 45,000, I don't know why I can't say that, 45,000 meters squared equals 212.1. I am working in meters. I'm asked to round to the nearest tenth. I technically had a 3 after here. This 3 is not greater than 5, so this number does not increase by 1. 212.1 meters is the shortest distance between points Y and Z. Another way to solve this problem is by using the distance formula. And a lot of you on the test brilliantly did this. So here's my distance formula. And what a lot of you did was you labeled this point with coordinates. So you said, okay, point Y is 1, 1, 2, 3, 4, 5, 6. If you were to give those X and Y values, it would be 1, 6. Point Z you said was 1, 2, 3, 4. And then how many in the Y direction? Remember, this is your Y, this is your X. So how many in the Y direction from here? 1, 2, 3, 4, 5, 6, 7, 8, 9. So you assigned these points coordinate values, so X and Y values. And then you went like this. Let's call point Y point number 1. So we'll give it our X and our Y with that 1 is just like a label. It's telling us this is point number 1. Because when we use the distance formula, we need to plug in our X1s and Y1s. Then you called point Z X2, Y2. And then you plugged in these values to the distance formula. So X2 minus X1. There's my X2, there's my X1. It's the distance between my X values. This could have been 0.1, this could have been 0.2. It doesn't matter which order you subtract the X's in, because ultimately you're going to be squaring this value. 4 minus 1 is 3, squared is 9. 1 minus 4 would give you -3, and -3 squared is 9. So it doesn't matter if you do 4 minus 1 or 1 minus 4, you're still finding the difference between the X's and squaring that value. Okay. Then my Y values, let's see, Y2 and Y1. My Y2 is 9. Minus, my first Y is 6 squared. Simplify. 4 minus 1 is 3. 9 minus 6 is 3. Squaring those values. Oh, I'm noticing that these values right here, these 3's, are the distances of these legs. 1, 2, 3 units. 1, 2, 3 units. Same as in the last problem. Cool. The distance formula and the Pythagorean theorem are related. Oops, I want black, not pink. Okay. So then we have 9 plus 9. Square root of 9 plus 9 is the square root of 18, which equals, and I'm going to find this in a decimal form, 4.2426. And I'm taking this to many places in my decimal answer because my next job is to find what this number represents in real life terms. So I remember this is like a map of a city or something, and I'm finding the distance between Y and Z. So Y might be my house, Z might be North High School. I want to find out what is this distance, and I'm being told that 1 unit equals 50 meters. So I just found out that the distance between these 2 points is 4.2426 units, but I want to find meters. So if 1 unit equals 50 meters, 4.2426 units is going to be how many meters? Well, let's multiply that number by 50, and I get 212.132. Round your answer to the nearest tenth of a meter. That is one place after the decimal. The number after it is not greater than 5, so this stays as a 1, and my answer is 212.1 meters. Same value as when we solved this using the Pythagorean theorem. Don't forget to convert your units to meters.